Okay, in this lesson, we're going to learn how to solve systems of equations by graphing. A system of equations is simply a set of two or more equations that contain two or more variables. And the solution for that system of equations is the set of values, or the x and the y values, that are solutions of every last one of those equations. So it's the points that on a graph that they have in common. If the system has two variables, the solutions can be written as ordered pairs. Remember, an ordered pair is your x and then your y, and that's just a specific point on a graph. And when solving in systems of equations, remember to find the values for all of the variables. Don't just find just the x value or just the y value. You got to find both of them. If it's three systems, then you're going to have three variables, and you'd have an x and a y and a z. Okay, but that's on down the road for everybody. Okay, so that's once you get into algebra 2 or whatever. So what we're going to do is we're going to look at the three basic scenarios that we have if we have a system of equations, okay? Because not all the systems of linear equations have graphs that intersect, okay? So there are three, like I said, there are three possibilities. You have intersecting lines that intersect, okay? And that is the solution for the system of equations, okay? That system of equations has one solution. If the lines are parallel, they're never, ever going to cross. So that means they're never going to have any points that they have in common. Okay, so there are no solutions for that. And then the third situation is if you have two equations that essentially are the same exact line. It's the same slope and the same intercept, same y-intercept. And that has infinitely many solutions because every single point on one line is also a point on the other line, all right? And so there are an infinite number of solutions for that. Okay, so let's do some examples, all right? So it says solve the system of equations. Y equals 4x minus 6 and y equals x plus 3. So what we're going to use is we're going to use Desmos in order to find this. So we're going to say y is equal to 4x minus 6. All right, and we're going to say y is equal to x plus 3. All right, when we do that, we can see here that the place where the red line and the blue line cross is this point right here, and we see that that is the solution. That is the point 3, 6. Okay, if you just hover over the point here, you'll see that it's 3, 6. Or if you want to actually, if you would rather just see it, take it, and you can you can zoom in if you're. It's a little bit difficult to do that because of only having it on the half of the screen. But the easiest way is to just go ahead and hover your pointer over that, and it'll tell you what the solution is. Okay, so and then if you want to check it, remember this is your x, this is your y. All right, that's your x, that's your y. So we can say, well, is 6 equal to 4 times 3 minus 6? Well, 4 times 3 is 12 minus 6, which is equal to 6. So 6 is equal to 6, yes. So that works. And is 6 equal to 3 plus 3? Well, obviously, we learned that in first grade, that 3 plus 3 is 6. And so that checks out. Okay, that's the 0.36 is your solution for both of those equations. Okay, so the next solution, the next system of equations is y is equal to 2x plus 9. All right, and y is equal to negative 8 plus 2x. All right. Well, now just in this small graph that I'm having here, it looks like those lines are parallel. Okay, and if I take and I zoom out, oops, I zoomed in. If I zoom out, it's easy to see that as far as I want to go, those lines are parallel. All right. So remember, if the lines are parallel, that means that there is no solution. Okay. Means there are no points that they have in common. All right. Solve the system of equations. Y equals 2x minus 7. All right. Y is equal to 2x minus 7. And 3x plus y is equal to 3. All right. Well, and we can see here that it actually does cross. It crosses right here, and that is the point 2, negative 3. All right. So that's the point 2, negative 3. You can see it pop up there. So the point 2, negative 3. And if we plug it in, remember this is the x, this is the y. All right. So negative 3, is that equal to 2 times 2 minus 7? 2 times 2 is 4 minus 7 is negative 3. And so that is the same. Okay. And is 3 times x plus y equal to 3? Well, 3 times 2 plus negative 3, is that equal to 3? Well, 3 times 2 is 6 plus negative 3. Well, 6 plus negative 3 is 3, and 3 is equal to 3. Okay? All right, so let's see here. Another one. All right, solve the system of equations. 2x plus 9, or no, I'm sorry, 2x plus y. 2x plus y is equal to 9. All right, and y minus 9 is equal to negative 2x. Well, wait a minute. It looks like there's only one line. Well, but look, that shows a green line there. But if I click, over here, that shows a blue line. So green line, blue line. Green line, blue line. So that is the same exact line. All right. It's just a different way of writing the same exact equation. So, this has an infinite solutions. Okay, an infinite number of solutions. All right. So solve this next system of equations. And one of the things I was just thinking about is that to get to this Desmos, just go to desmos.com in case you don't know how to do that. Go to desmos.com and click on where it says graphing calculator. Okay? All right. So we have x plus y is equal to 5. All right. And 3x plus y is equal to negative 1. Okay? And we can see here that that crosses right here at negative 3, 8. All right? So negative 3 and 8. All right? Plug it in. Okay. Negative 3 plus 8 is equal to 5. Well, yeah, we negative 3 plus 8 is equal to 5. And 3 times negative 3 plus 8, is that equal to negative 1? Well, this would be 3 times negative 3 is negative 9 plus 8. Well, that is equal to negative 1. Okay, so that checks out as well. All right. All right, so we have a word problem. It says a fishing boat leaves the harbor traveling east at 16 nautical miles per hour. After it travels 40 nautical miles, a Coast Guard cutter follows the boat traveling at 26 knots. After how many hours will the Coast Guard cutter catch up with the fishing boat? Okay, so we're just going to say y is equal to 16 knots, 16 times however many knots we have, okay? Okay, and we're going to say it travels 40 miles, okay? It gets a 40-mile head start, all right? So after it travels 40 miles, the Coast Guard follows the boat. It just says y is equal to 26x, all right? And we want to know when is the Coast Guard here. This is the Coast Guard. This is the boat. Okay. All right. So we want to know when are they going to arrive at the same point. So we're going to say y is equal to 16x plus 40. Okay. And we're going to say the Coast Guard y is equal to 26x. Okay. How many hours? Okay, and so it says how many hours. So we need to find where they cross. Okay, so when we do this, it's a little bit hard to see. Well, let's see here. Let's zoom in a little bit. Okay, and we can see here it's going to be it's going to be right in this area right up here. Okay, and it's obviously going to cross right in here someplace. Okay, it looks like if somebody said ask how far out it would catch it, well, it'd be at 104 miles. Okay, but we want to know how many hours it is. So we're going to come on down. Okay, and actually the easiest way would be maybe to zoom out. Okay, it's going to be this line right here. Okay. So it's going to be Now, it looks like it's going to be about 3 hours or so. Okay, so if we look, if I come on up here, so yeah, 1, 2, 3. Actually, it looks like it's probably going to be more like 4 hours. 3, it's going to be like 4 hours. Okay, because if I look here, 1, 2, 3, 4, 4 hours. So let's plug in 4 hours. So when we do this, 26 times 4. Okay. Get my calculator. Come on. Okay, I'm going to say 26 times 4 is 104. Okay. Okay, or if I say 16 times 4 plus 40 is also 104. Okay, so it would intercept the boat at 4 hours. Okay, so that's how we do that. And for some reason, and I don't understand why it didn't, but for some reason it did not give me the point here. But there's you can just look where it is on the graph. All right. So anyway, so if we come back, that is it for this lesson. Okay. And if you have any questions, make sure that you ask me. Make sure that you use this Desmos to graph those equations. And we will talk to y'all later on.